All right, guys, welcome back to this class. This is Learning with AK. We're going to continue from what we stopped yesterday. Yesterday, we looked at quadratic equation, and then we look at how you can be able to get your values for x and y when you have a table in terms of what problem. However, today I'll be helping you to plot it on the graph. I told you yesterday that we're going to continue from there. So today we're looking at how to plot your values on the graph. Don't forget that yesterday we looked at two different equations, and at the end, I told you that you will have range of value for both x and y. So x and y. So say for example, we have -2, -1, 0, 1, 2, 3, 4, and 5. Now you know how to get a y value. I'm just going to extrapolate values, figures. Okay, I'm not going to use a real figure. But the aim of this class is for you to be able to know how to plot your graph, That's the purpose of this class. Okay, so let's assume this is a 5, 0, -2, -1, 3, 2, 4, and let's say 7, for example. Now, what is important is for you to plot this on a graph, you need to know some basic things about your graph. This is your graph book. You know that basically we have axis, x and y axis. Okay, and it's your positive x-axis, it's your positive y-axis. However, for the purpose of this class, when you're doing quadratic equation under using graphical method, you always have values ranging between x and y, which are usually negative sign. For example, this x you have -2 and -1, this y too you have -2 and -. So there's a need for you to introduce negative to the basic thing you know. So which means that once your line passes through the origin downward, it is negative. So this guy will be your corresponding negative y. And here, extension of this one from your origin is your negative what? X. So on this axis here, you plot your x, your negative x value, and here you plot your negative y value. And of course, here you have your positive y and your your positive x. Okay. So the next thing is to look at your table and peruse through your figures and all that. However, one thing is very important, which is scale. Your scale is very important. Whatever you're going to do here, the first thing to do is to be able to choose your scale, to choose the right scale. Now, your scale, what's important with scale? Your scale, makes your graph or your graph look big or small. Okay, and making the right choice for your scale makes your work very neat and of course self-explanatory to anybody who's going to pick up your graph. Okay, so in doing that, they will come back to this. If you have a graph, you can pick it up, and look at it. Now, basically, in any graph, you will see that it is divided into small checks. Okay, small checks. Those checks are very important. Also, if you look at your graph, you have some thick vertical lines and thick horizontal lines. Okay, thick vertical lines and thick horizontal lines. Between the this thick line and the next thick line is 5 box. Okay, is 5 box. So you have five box in between one thick line to the other. One thick line, you have 5 box of 5 cube of this 1, 2, 3, 4, 5. You have a thick line 1, 2, 3, 4, 5. You have another thick line and so on like that. Same thing for your horizontal. Between your horizontal two, in between both your horizontal and vertical, you have 5 box in between. Okay, 1, 2, 3, 4, 5. You have this 1, 2, 3, 4, 5. You have this. What I'm saying is that you have this box. Yeah, you have something like this in each of this. So basically, if you put your ruler there, from here to here is 1 centimeter on every graph book. From five, the first five, 1, 2, 3, 4, 5, and 1, 2, 3, 4, both vertical horizontal, that such that you have a thick line here and a thick line here. You have 5, 5 across board. So that is 1 centimeter. The next box is another 1 centimeter. The next one, another 1 centimeter. You can use your ruler to verify that. Now, why is that important? That is important for you to be able to choose your scale, to know how big or how small your graph will look like. Now, coming back to my, having to know this about your graph, coming back to your value, you need to know what is the least value I have for my x. When I mean the least value, I mean the negative axis, and what's the maximum on the positive side. Here, if you look at the x-axis, the least value we have here is -2, and the maximum value we have here is 5. That's on the x-axis. Now, on the y-axis, what is the least value we have here? That's -2, and the highest value we have here is what? 7. Now, since you know that, then now come to your graph. Now, don't forget, to this end is your negative x. To this end is your positive x. Y to this end is your positive y. To this end is your negative y. What then do? We know our value, range of value. We understand our graph book better now, using the check and the distance. Then we come to our scale. Now, since the least value you have here is -2 to this side, okay, and the highest value you have here is 5, then you now need to come to your, and the highest we have for our y is 7, the least we have is also 2. You come to your graph book, such that since x is -2, y is -2, that means the y value is coming this, beneath here, and x value is coming this way. So you have the least value at both ends. Hence, you can choose to ensure that the scale you have here, you have least space here, you have more space to this side, so as can occupy your 5, accommodate your 5, and here you can also accommodate your 7. Secondly, we want to choose our scale now. Now, if you count each of these boxes, you can also use your graph book to check. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 of this small box. That means that the entire of this will be 11 centimeter. That's what I have. However, this is not a standard graph, because this is this graph from each line to the other one is 2 centimeter for this graph. But your basic graph book is 1 centimeter. So this is not a standard graph, so it's not widely acceptable. Okay, but I'm going to use this based on this. Each of these is 2 centimeter, but a regular graph, each of these box is 1 centimeter. So I'm just using this one as a case study. So what you need to know is that once you have your graph, from this thick line to the next thick line, put your ruler there, it will give you 1 centimeter. So work with that. I'm working with what I have. Now, since I can count 11 across board, the highest I have here is 7, and the least I have here is 2. That means that if I say that my scale is 1 centimeter to represent 1 unit on x-axis, let me start with y-axis. On y-axis, now what 1 unit means that for every 1 centimeter, I will take it as 1. For every 1 centimeter, I'm going to take it as what? 1. That's what 1 unit means. If I say I want to make 1 centimeter represent 2 units, that means that for every 1 centimeter, it is 2. So that means from this point to this point, which is 1 centimeter, it will be what? I'm going to write 2 here. The next 1 centimeter I'm going to write is also 2. So 2 plus 2 will be what? 4. And that's the way you write it, like that. Okay? Like that. So your scale, that's the definition of your scale. So every centimeter you are choosing represents a particular unit. Okay, every centimeter you are choosing represents a particular unit. So in this context, because of the value I have, I'm working based on the value I have here. -2 the least, highest is 7. And when I counted here, I counted 11 centimeter. Okay, I'm assuming that from here to here is 1 centimeter. Please, let's get that fact. I'm assuming, which is the standard one, that from here, this thick line to the next thick line is 1 centimeter. So that means that since I have 11, it is convenient for me to count 1, 2. 3 downward here and count 1, 2, 3, 4, 5, 6, 7. Okay, that's to accommodate the y-axis. Okay, so what I'm just simply saying, here is that I might not be able to draw a full graph, a full-blown scale graph, but the most important thing is that you understand what I'm saying. So I'm going to this my horizontal line. I'm going to do it in such a way that it's going to be closer because the least value I have here is what? -2. So while you are doing that, you're on your own side, it should be lower this way, such that this is 0. I have -1, I have -2, and I have -3. Don't forget, I counted 11 here. So that means that this is 1, 2, 3. This is 1 centimeter. From here to here is 1 centimeter. From here to here is 1 centimeter. And that's why it is 1 each. The difference between this one is 1. This is 1. Like that. So I'm not going to continue. 1, 2, 3, 4, 5, 6, 7. Okay, for this axis. I'm also going to come here to the horizontal for x-axis. The least value I have here is what? 2. And the maximum here I have is 5. So I'll come here to choose my scale. How many do I have here? 1, 2, 3, 4, 5, 6, 7, 8. 8. And I have 5 on this side, positive, and 2 here. So that means I can still say that on x-axis, 1 centimeter to represent 1 unit on x-axis, which means that here I have 0, 1, 2, 3, 4, 5. 0, -1, -2. If you count everything, I have 1, 2, 3, 4, 5, 6, 7, 8. So it accommodated this axis, and also this was able to accommodate this side. Now I'm doing this because of the unit I'm using. If I decide to change the unit to maybe 2 centimeters represent whatever unit, it will be blown up. However, now I haven't done this, which is on your graph. You can start plotting. When x is -2, y is 5. So you trace -2 to 5. Here, when they meet, you are going to asterisk it. When x is -1, don't forget this is your x-axis and this is your y-axis. X and y. Okay. When x is -1, y is 0. This is -1 is 0. So here. So you can asterisk this point. Okay. When x is 0, y is -2. When x is 0, y is -2 here. Concentrate it down and here. When x is 1, y is -1. When x is 1, y is -1 here. When x is 2, y is 3. When x is 2, y is 3. You asterisk it here. When x is 3, y is 2. When x is 3, y is 2. Then when x is 4, y is 4. 4, I trace it here, 4. When x is 5, y is 7. X is 5, y is 7. Now this junction, then you plot your graph. Now this will give you like a curve graph. So you look at the points. It's not compulsory I have to pick all the points. Okay, I have a point here, so you can just circle to know where you have your intersection, so that you know how to draw your. Now since I have this, it's convenient for me to draw it this way, so I can leave this out. It's not compulsory. Okay, and don't forget that the values I have here are not real value. It's just value I just came up with just for the purpose of the class. Okay, then you have your graph. That's where you plot your quadratic graph. Please try yours at home, and whatever it is, let me know. However it is that you're able to get, whatever you're able to get, let me know in the comment section. If it's easy, if it's difficult, so that I can revisit it again. Thank you and have a wonderful day. The next class will be looking at um, the further question, because from your graph you can still get other questions. Okay, you can be asked to get the value for y when x is this, find y. You should find the uh, where y is, has the lowest value, where x has the lowest value. What is x when this is that. There are some other questions you can get from your graph. So for today I'm going to stop here. Next class I'll see you. Ciao.